Welcome to video 5, the last video where we are looking through the trial exam solutions. Picking up with question 33, a company stocks two different grades of sandstone paving. We've got grade A that sells for $60 a square metre and grade B that sells for $40 a square metre. A landscaper is going to purchase a total of 50 square metres of sandstone paving, including some of each grade. In doing so, their total cost was $2,400. Let X represent the number of square metres of grade A paving, and let Y represent the number of square metres of grade B paving. We want to write down two equations for X and Y and solve these equations graphically. From that graphical solution, we want to determine how many square metres of each grade of sandstone paving were purchased. All right, so we know that we're getting some of X and some of Y, our two different grades. How many are we getting? Well, it tells us a landscaper purchases 50 square metres. So that means we're going to buy some quantity of grade A, X, and some quantity of grade B, Y. So that means that whatever we're buying in X and Y has to be a total of 50 square metres. Right? X is the number of grade A square metres that we're buying, and Y is the number of grade B paving that we are buying. So we know that X plus Y is going to be 50 because we're getting a total of 50 square metres. The other piece of information we've got is that we are paying $60 for every X and we're paying $40 for every Y. And that total cost is going to be $2,400. Right, so $60 times the number of X plus $40 times the number of Y is going to equal $2,400. So those are our two equations that we want to now graph. So let's start with our X plus Y equals 50. Let's pick a value. We can pick any value we want because it's going to give us a point on our graph. And we're going to do it for two values, so we get 2 points. Once we've got 2 points, we can draw a line that connects them up. So you can pick any 2 points. Let's make our life easy. Let's pick when X equals 0. So if X is 0, well, then we know Y must be 50 because 0 plus 50 equals 50. So that's handy to know. There's 1 point. The other thing we've got is if Y is 0. Well, if Y is 0, then X must be 50. All right, so straight away, just by picking nice easy points, namely when X is 0 and then when Y is 0, we can find out our appropriate Y and X that corresponds. So now we have 2 points. We have the point 0, 50, and we have the point 50, 0. So if we were to plot those on our graph, we're going to get that line there that runs from up the top 0, 50 down to the bottom 50, 0. So we found our 2 points and we've joined them up with a line. Guess what? We're going to do the exact same thing with the second equation, and we're going to pick the exact same values. So let's start off with X being 0. So when X is 0, well, then our 40Y must equal 2,400. So then what's 1Y going to be? Well, I divide both sides by 40 and we get that Y must be 60. So there's 1 point. When X is 0, Y is 60. Now we're going to do the same thing for Y. We'll set Y to 0. So when Y is 0, our equation becomes 60X equals 2,400. Well, what's 1X going to be? We divide both sides by 60 and X is going to be 40. So now we have 2 points for our second line, 40, 0 and 0, 60. So again, I want to mark those 2 points on my graph and then connect them up with a line. And we get that blue line there. It runs from 0, 60 at the top all the way down to 40, 0 at the bottom. So we want to find graphically the solution to those two equations. What does that mean? Where do the two lines cross? So where does our red line and blue line meet? Well, that's that big red circle right there in the middle. That's our graphical solution, because that's the 1 point where both of those two equations work. That X plus Y will equal 50 and 60X plus 40Y will equal 2,400. It's at that point. So my X-axis represents the number of grade A sandstone that I'm getting, and my Y-axis represents the number of grade B sandstone that we are getting. So I can just read the values straight off that graph. So from the x-axis, I'm just going to come down from that red dot and we've got to hit 20. So that means we're buying 20 units of grade A. And I carry from that red dot across to my y-axis and we get 30. So we've got 20 square meters of grade A and 30 square meters of grade B. Question 34. Electromagnetic waves include radio waves, ultraviolet rays, and visible light. The frequency f measured in cycles per second of such waves is inversely proportional to the wavelength L measured in meters. So what that inverse proportion means is that as one gets bigger, the other is going to get smaller, right? The inverse relationship, right? As one gets smaller, the other gets bigger. So a particular color of visible light has a frequency of 5 times 10 to the 14 cycles per second when its wavelength is 6 times 10 to the negative 7 meters. Show that f equals 3 times 10 to the 8 all over L. So there's our inverse relationship right there. Now there are 3 ways that we can show that that actually works. One is that I can replace 3 times 10 to the 8 with some letter k, for example, and then substitute in my f and the value for L that we were given, and then see if k equals 3 times 10 to the 8. The other way is I can substitute in the frequency and then solve it to see if the L is what's given, or I can substitute in L and see if the f is given. It really doesn't matter which way you go because you're going to get the same result. I think the easier way is to substitute in our value for L, so that's what we're going to do. So we know L is 6 times 10 to the negative 7, that was given to us. So I'm just going to substitute that into our equation. And we get that f is equal to 3 times 10 to the 8 all over 6 times 10 to the negative 7. Now, if you remember your index laws, that negative 7 means we can just do the reciprocal of it and have a positive. So if we had 10 to the negative 7 on the top, I could bring it to the bottom and change the negative to a positive. But what we've got is 10 to the negative 7 on the bottom, so that means I'm going to bring it to the top to make my negative a positive. So what we end up with is 3 times 10 to the 8 times 10 to the power of 7 all over 6. Again, another index law, 10 to the power of 8 times 10 to the power of 7. We have a common base, they're both 10s, so I can just add my powers. So I can go 10 to the 8 plus 7, 8 plus 7 is 15, so that's just going to be 10 to the power of 15. What we're left with then is 3 over 6. Well, that's a half. That's going to simplify down to 0.5. So what we have there is 0.5 times 10 to the power of 15. Now this needs to be in scientific notation, and that's not quite scientific notation. We can't have a leading 0 out the front. Right? The proper scientific notation is it must be a number that's a non-zero leading. So what that power of 15 means is that that decimal point will move 15 places to the right, and that will be what our actual number is in standard notation. In scientific notation, we simplify it down and we just say 10 to the power of 15. So I want to move that decimal point 1 place to the right. So if I'm moving it 1 place to the right, that 15 has to give me 1, basically. So that 15 is going to drop down to 14. So what that 0.5 times 10 to the power of 15 is the same as saying 5 times 10 to the power of 14. Now, I've moved my decimal place 1 place to the right so that that 0 out the front goes away, but I have to take 1 away from that power of 15. And then when we look back up, lo and behold, we were told that the frequency was 5 times 10 to the power of 14. So we have shown that f does indeed equal 3 times 10 to the power of 8 all over L. Now part B, we have an infrared wave that has a wavelength of 2 times 10 to the negative 4, and we want to find out what is its frequency. Guess what? It's the exact same thing we just did. This time we've got a wavelength L of 2 times 10 to the negative 4, and we want to find out what f is. It's going to be a different value of f, but the process is the same. So L is 2 times 10 to the negative 4. So we substitute that into our equation. Again, that negative 4 means I can bring that 10 up to the top and change the negative to a positive. So we've got 3 times 10 to the 8 times 10 to the 4 all over 2. 10 to the 8 times 10 to the 4, well, that's going to be 8 plus 4, 12, so 10 to the power of 12. 3 divided by 2, well, that's 1.5. So what we're left with is 1.5 times 10 to the power of 12. Question 35. So we've got a network here showing the maximum rate of water flow in litres per minute through a system of water pipes from a source at A. A is asking us what is the maximum amount of water that could be delivered to F in litres per minute. So we want to work out what's our maximum flow from A through F. Now I've got lots of options of where I can start, but let's start across the top. So from A to B, we've got 100. And if I look to B to E, I've got a number bigger than 100. E to F, again, a number bigger than 100. So that means the smallest number across the top there is 100. So I'm going to take 100 through the top. So I'm going to cross out that 100 and make it a 0. 150 will cross that out and leaves us with 50. I take 100 out of that 400 and it leaves us with 300. So what I've done now is I've pulled 100 through that system. So what have we got next? Well, we can go across through the middle or we can go down the bottom. Let's have a look at going through the middle. So I've still got 300 from E to F. How can I get up to E? I've got 200 I can bring up, so I can fit 200 through the system. So A to C, I can take 200 through the system. So we cross out the 600 and write 400 because I'm taking 200 through. That 200, we're going to cross that out and write 0. 300 will take 200 away and just leave it with 100. So now I've pulled another 200 through the system. All right, so from A to B, I can't take anything more through that way. From C to E, I can't take anything more through that way. I can take another 350 though from C through F. So I go back from A to C, there's 400, so I can take 350 through there as well. So let's cross out that 400 and write 50 because I'm going to take 350 through. So that means I can cross out that 350 from C to F and write 0, and I've pulled another 350 through the system. All right, every time we take these numbers through, we're crossing them off, so we know we can't take that through anymore. So now I've got 200 that I can take down from A to D, but I can only take 100 from D to F, so I'm only going to take 100 through. So we cross out the 200 and write 100. I cross out that 100 from D to F and write 0, and I've pulled another 100 through. Now I've put a cross there from A to B because that's a block. I can't take anything through there because there's a 0. Likewise, if I look at C to E, that's a 0, so I can't take anything that way. C to F is another 0. I can't take anything that way. D to F is also a 0. I can't take anything that way. Now the reason why I've blocked off those is to see, is there any path that I've not blocked off? Well, I can't go from A to B, that's blocked. I can go from A to C, but from C I can't go anywhere, so that's in essence blocked. From A I can go down to D and then up to C, but that's blocked, that doesn't help me any. And from D I can't go across to F. So because those are all 0s and all of my paths are blocked off, there is no way else I can get through that system. So how much can we get through? Well, it's going to be 100 plus 200 plus 350 plus 100. Those are the amounts that I can get through. So when I add those numbers together, we get 750 litres. Part B is the cut that's shown in the dotted blue line on the diagram, a minimum cut. So remember our rules for minimum cuts. If it's the smallest possible number that I can get by doing a dotted line through our network, that represents the maximum flow I can get through. So if that blue line, for example, is 750, well then yes, it's a minimum cut. If it's not 750, well then it's not a minimum cut. So let's add up the numbers that it passes through. So it passes through 150, it passes through 200, it passes through 350, and then it passes through 100. So those are the numbers I want to add together. All right, passes through 150 from B to E, 200 from C to E, 350 from C to F, and then 100 from D to F. When we add all those numbers up together, we get 800 litres. 800 litres is bigger than that 750, so therefore no, it is not a minimum cut. Now, if by some weird chance when we did that, we got a number that was smaller than 750, it either means that our answer in A is wrong, or that something that we have done adding up our numbers with our cut is wrong. All right, so if for whatever reason one of our numbers works out smaller than from a cut than what we had worked out for our flow, we know we've made a mistake somewhere. Part C, when the maximum flow occurs from A to F, how much water in litres per minute passes through C? All right, well, we know that we've got 600 coming in from A and we've got 50 coming in from D. So 650 is coming into C, but the question says how much passes through it. So even though 650 can come in, we can't get 650 out the other side. How much can we get out the other side? Well, it's going to be 350 plus 200. So we can only get 550 through C, right? Because it says how much passes through, not how much is coming in, not how much is coming out, how much passes through. Because there will be situations where the amount coming in is not the same as the amount coming out, but that doesn't necessarily mean that the amount coming out is going to be the answer that can flow through, right? Because it could be less coming in than what's coming out. So it is important to check both sides. So in this instance here, 550 litres, not 650. For part D, the water flow now through C that we just calculated of 550 litres is going to be reduced to a maximum of 480 litres. So that's going to have the knock-on effect of our network not being able to manage to get through the total 750 litres. So in order to maintain that 750 litres that we got in part A, the capacity of a single pipe or edge is going to be increased by the least amount possible. So imagine that we've decided we're going to increase one of the pipes. There's going to be a cost associated with that. We want to keep that cost down, so that's why we are doing it by the least amount. So which pipe should we choose, and by how much should its capacity be increased? So the first thing we need to look at is our 480 litres. We had 550, we're dropping it down to 480, so that means we have a reduction of 70 litres. So somewhere we're going to have to add on 70 litres. So where can we add on our 70 litres? Well, there's no point looking at anything in the middle, because everything in the middle's got to go through C, and C's already been decreased. So now we want to look at some of the other numbers. Well, we had from A to B, we had a total of 100 go through there. So if we would increase that by 70, but then, so that'd give us an extra 73, but then when we get to B, it's 150. So there's 20 that we're now losing. So we'd also have to increase B to E by another 20. So now we're increasing it by 90 in total. So that's not the minimum amount possible. We need to find one single path. So we remember we went from A to D to F, we took through 100, and that left 100 space from A to D. So if I could fit 70 through there, but from D to F, I can only fit 100. So realistically, I want to increase D to F by 70 in order to get that extra 70 through. Right, because those are the only two options, is that I increase A to B by 70 and then B to E by 20, so that's an increase of 90, or I increase D to F by 70. So obviously 70 is less than 90, so that's our best option, increasing D to F by 70 litres. Question 36, the last question. The diagram below shows an isosceles triangle XYZ with side length XZ being equal to side length XY, and both of those being equal to K. YZ across the bottom is equal to 10 centimetres, and the angle YXZ at the top is equal to theta. By considering the area of the triangle, show that sine theta is equal to 10 times the square root of K squared minus 25 all over K squared. Now, this question here is part of what's called the common content. So not only is this exact question in the standard 2 paper, it would also be in the advanced paper as well, because it's part of the common content. So because it is both for standard and advanced, you should expect that this is going to be one of the harder questions. All right, so we want to consider the area of a triangle. Well, hopefully we remember area of a triangle, half times the base times the height. Well, we've got a base, we know that's going to be 10, but what is our perpendicular height? We haven't got one, right? We want that height length there. Now, I haven't got that, but we can figure it out. How can we figure it out? Well, that dotted line is going to make a nice 90-degree angle down the bottom, and because it's an isosceles triangle, it's going to split those two smaller triangles to be exactly the same size. So they're both going to have a height of h. The base of both of them is going to be half of 10, namely 5. So what we're going to need to do to find our height, given that we know that our hypotenuse is k, is we can use Pythagoras' theorem. Remember that a squared plus b squared equals c squared. So c squared is our hypotenuse, so c is going to be k. It doesn't matter if we pick a or b to be the height. So let's use a as our height, and then b will be our base, which is 5. So what that means is that h squared, our height, plus 5 squared is going to be equal to k squared. How does that help us? Well, remember our goal here is we want to work out what is h. So if I can rearrange that now to get h by itself. So if I take 5 squared from both sides, what we're going to get is that h squared is equal to k squared minus 5 squared. Now, if I want to find what h is by itself, I'm going to take the square root of both sides. So then h is equal to the square root of k squared minus 5 squared. So now, when we look back down to our area being half times base times height, well, we know our base of our big triangle was 10, and our height now, we've just worked out, is k squared minus 5 squared, and then the square root of all of that. So I can substitute all of those numbers in. So the area of the triangle is a half times 10 times the square root of k squared minus 5 squared. Now I can simplify that down. A half times 10, well, that's going to be 5. And then obviously 5 squared is 25. So we're going to be left with the area of our triangle being equal to 5 times the square root of k squared minus 25. Now that is not overly helpful in looking at our final goal, right? We want to get that sine theta is equal to some number. There's nothing in there about any a for area. So while I've worked out the area in the way that we have always learnt how to solve the area of a triangle, when we don't have a 90-degree angle, we can work out the area of a triangle using an angle. Remember, and this should be on your summary sheet, that the area of a triangle is equal to a half times a times b times the sine of c. Now remember that our angle c is going to be between the side lengths a and b. Now we've got a theta up there, so that's obviously the angle that we're going to want to use, because that's our goal. Remember, we want sine of theta. So if I'm using that theta at the top, which two sides of my triangle are going to be a and b? A and b are going to be k and k. All right, we are not going to use the 10 centimeters in this example. So what we now can do is we can substitute in k for a and a k for b, and then theta for c. So that our area is now going to be equal to a half times k times the sine of theta. Now I can simplify that down. K times k, well, that's going to be k squared. And a half, well, that just means I'm dividing it by 2 rather than timesing it by a half. So what we get then is k squared times the sine of theta all over 2. That's another way that we can express the area of our triangle. So my area of the triangle can be expressed as 5 times the square root of k squared minus 25, or the area can be written as k squared times the sine of theta all divided by 2. So if the area in both of those situations is going to be the same, so what I can do is I can say, well, the area equals the area. That should be pretty straightforward, saying it like that. But what that means is that the 5 times the square root of k squared minus 25 is going to be equal to my k squared times sine theta all over 2. So I can write that those two expressions are going to be equal to themselves. So now where do I want to go? Well, let's look at my ultimate goal. I want to show that sine theta equals 10 times the square root of k squared minus 25 all over k squared. So I want to get sine theta out by itself. So if I look at the left-hand side there, I need to get rid of the k squared at the top and the 2 on the bottom. So what I'm going to do is I'm going to multiply both sides by 2. So then that we get the k squared times sine theta is equal to 10 times the square root of k squared minus 25. And now I'm going to divide both sides by k squared. And we're left with sine theta is equal to 10 times the square root of k squared minus 25 all over k squared. Right, that's what we wanted to show, that is indeed what sine theta equals. We've shown that now by finding the two different ways that we could work out the area and having them equal. And for part B, given that the area of the triangle is 60 centimeters squared, find the size of theta to the nearest degree. Right, so we were talking about finding the area if it was just some random amount, but now we're told the area is going to be 60 centimeters squared. It doesn't necessarily mean it has to be, but we just say, well, if it was 60 centimeters squared, what must the size of angle theta be? Well, in order to work out our angle theta, we're going to need to first work out what is this length k. So in order to do that, remember we found our area in terms of k, and that was that a was equal to 5 times the square root of k squared minus 25. So we know the area is 60, so I'm just going to substitute that in and say that that has to equal 60. So my goal, like I said before, was to get k by itself, so I'm going to get everything away from the k on the right-hand side. So the first thing I'm going to do is divide both sides by 5. So we get that 12 is equal to the square root of k squared minus 25. Now I want to get rid of that square root, so I'm going to square both sides. So 12 squared is 144, and that's going to be equal to k squared minus 25. I'm now going to add 25 to both sides, and we get that 169 is equal to k squared. Now if I take the square root of both sides, we get that k is equal to 13. So the only way that a triangle with a 10 centimetre base can equal 60 centimetres squared in this instance is if our side lengths are 13 centimetres long. That's nice to know. We are slowly getting there, but we haven't yet found out what is the size of the angle in that triangle. Well, the other thing that we just found in part A, it was given to us and we showed that it worked, is that the sine of theta is equal to 10 times the square root of k squared minus 25 all over k squared. So I'm now going to solve that to find out what sine of theta must be. Now, it's nice that I worked out that k is equal to 13, but if I look at that equation, what I've got there is k squared over k squared. Well, I already have on the left-hand side there that k squared equals 169, so I'm just going to substitute those straight in. All right, so that's going to be equal to 10 times the square root of 169 minus 25 all over 169. Now I can type that straight into my calculator. I don't have to simplify that any, and the calculator tells me that that's going to be 0.710059. That's the sine of theta. I want to know what theta is. So what I have to do now is take the inverse sine of that 0.71 number. So the inverse sine of that 0.71 number is going to give me theta. Again, using the calculator, don't clear out the number, leave the number that the calculator found in there, so you can just go inverse sine of the answer. Then you're going to avoid any rounding errors, and that tells me that theta is going to be 45 degrees. Now remember, question 36, like I said, is part of the common content, so it's going to be in standard 2 and it's going to be advanced. The last question here was by far the hardest out of the whole paper, so don't feel too bad if you found it hard, because it's definitely meant to be there. This is what would be called a band 6 question. And that brings us to the end of the solutions for standard 2. I hope I've explained the answers well enough that you've learnt something along the way. Thank you very much for your time, and I hope you have indeed found it educational.